What's going on, Algebros? It's Mr. C here, and in this video we're going to solve one example of a special case absolute inequality. And that being part A here. Our instructions say solve the following inequality and graph the solution set. Alright, in example part A we have the absolute value of 3x plus 2 is greater than 0. And what makes this a special case absolute value inequality is the fact that the right hand side is 0. Alright, if the right hand side number is positive, we know that we can apply the rules in the table from earlier in the notes and be on our merry way. But here it's a little bit different. What we want to do is figure out, okay, values of x such that when we take the absolute value of 3x plus 2, we get a positive number, because that's what being greater than 0 really means. So the idea here is that, or I guess I should say the logic is that, well, you know, so long as you're not the number 0 itself, you're going to have an absolute value that's greater than 0. Okay, in other words, any positive number has an absolute value greater than 0, and so does any negative number. So there are two ways that this thing can go. Either 3x plus 2 is greater than 0, okay, that is just indicating that the expression is a positive value, or 3x plus 2 is less than 0. Alright, that's us basically saying that the expression could be a negative number, okay, because the absolute value of a negative number would have an absolute value greater than 0. So we wind up getting an OR compound inequality, and we're going to go ahead and solve each of these separately. Before we do that, let's draw our little boundary line to make sure we don't accidentally write it as a compound, compact and compound inequality. And let's go ahead and start solving the 3x plus 2 is greater than 0 inequality. So we'll go ahead and subtract 2 from each side. We get 3x is greater than negative 2. Divide by 3. X is greater than negative 2/3. Alright, similar steps with the second inequality. Let's subtract 2 from each side. We'll get 3x this time is less than negative 2. And upon dividing each side by 3, we get x is less than negative 2/3. Alright, so at this point, it's either x is greater than negative 2/3 or x is less than negative 2/3. So it does want us to graph the solution set, so let's graph up a number line. And here, if you take a look at it, we're really comparing x to one number, and that number is negative 2/3. So I'm going to put negative 2/3 on the number line, and just ask myself, okay, well, based on the inequality, which side of this number should I shade? Well, if we look at the first inequality, x is greater than negative 2/3, we're going to want to shade to the right of negative 2/3. Now, since there's no bar underneath that inequality symbol, we're not going to include negative 2/3. So what that means is that we'll put a parenthesis on negative 2/3 facing in that direction of shading. As for the second inequality, it says x is less than negative 2/3. Okay, so this asks us for x values that are to the left of negative 2/3. So I'm going to shade to the left of negative 2/3 on the number line. Again, there's no bar underneath this inequality symbol. Therefore, we'll use a parenthesis facing in that direction of shading. Now, it would appear as though the solution is all real numbers here, but that's actually not the case. There is one number that's not being included on this number line. Can you figure out which number that would be? That number would be negative 2/3. Alright, so we have numbers shaded to the left of it, serving as some solutions, and we have numbers shaded to the right of it, serving as some solutions. But the number negative 2/3 itself is not included in any part of the shading. So it's not a value of x, that's a solution. Alright? Well, without further ado, here's the interval notation, which represents the solution to this entire absolute value inequality. Parentheses negative infinity, comma negative 2/3, parentheses on the negative 2/3, and we're going to union that with parentheses negative 2/3, comma infinity. And that right there is the interval notation representing the solutions to our first special case absolute value inequality. Alright, in the next video I'll go ahead and solve example part B, and in the video following that I'll go ahead and solve example part C. See you then.